So we're going to be looking at our new book. Has chapters 5, 6, 7, 8, and I think 9. I think that's as high as we go. Yep, 9. And the first 3 chapters deal with geometry. Oh. So we're going to be talking about lines. And actually, I think it's kind of an interesting title because the vast majority of the lesson isn't about lines, but it's about the angles that are formed from lines. So I'm going to put in parentheses here, and angles. So a lot of times when we're starting with geometry, and this was true when I taught the geometry course, that always the first couple lessons were almost all vocabulary. Certain chapters in a geometry class would have upwards of 30 to 40 vocab words in just one chapter, because every time we came to a new concept, a new idea, we had a ton of vocabulary. And then the subsequent chapters after, it would slim down. And there was a couple times where we had less than 10 vocab words in a chapter. And then we get to something different, and then there'd be like 30 words again. So vocabulary is very important for us to understand. So if there's anything you don't understand, you need to make sure that you're questioning and asking questions and so on and so forth. Today is 3-9. So let's start with the 2 types of lines. Now, a lot of you said lines are parallel. Okay, that's not very specific. So we want to get into the details of what makes a line parallel, what makes it perpendicular. So if you notice the chart has symbols. It has define it in your own words. And I'm actually going to make sure that you guys have the appropriate words. So I'm going to give you those words. So I'm going to give myself a little bit of room here. You're going to draw it. And you're going to describe it. Real world. What might you see that represents these? So we're going to have 2 columns, and we're going to start with parallel lines. So interestingly enough, the symbols that represent parallel lines look like 2 parallel lines. Now, what's true about parallel lines? What makes them parallel? Susie? They'll never intersect. In fact, I like those words better than saying they're lines that never cross. Well, we want to get some good words here. So let's talk about lines that never intersect. No matter how long we draw them, they will never intersect. Now, we talked about parallel lines when we were dealing with the systems of equations. And we were able to look at 2 equations, and we knew immediately if they were going to be parallel. Do you guys remember what were the criteria to look at 2 lines and say, oh, I have parallel lines? What is true about the equations of lines that are parallel? Okay. So they have the same slope. They had one thing that's the same, and then they had one thing that was different. What was the thing that was different? Slopes are the same, but what's the different piece? Remember, what are the 2 key things you're told about when you look at an equation of a line? Melissa?
The y-intercepts.
What about them? Yep, so we say different y-intercepts. Okay, so symbols, funny enough. 2 lines next to each other, like lowercase l's, that will never meet. That's the symbol. So drawing it, now, because they're parallel lines, we need to add something to that drawing there. We need to add the arrow caps to indicate that these go on forever. Now, I actually have another symbol that I want to share with you. I think the book shared it. And you need to understand, I taught geometry. Yeah, they did. I taught geometry for 10 years, so I always think about what's important in that class. So what you can also do to indicate that you have parallel lines you can draw little red triangles, like little red arrow caps. That indicates those lines are parallel. Often in geometry, we can't trust what we see. We can only trust what we're told, okay? So I could try to assume the lines are parallel, but with those red little arrows in the center, that's telling me they are parallel. So I can trust the second drawing more than I can the first. Does that make sense? I need to be told, okay? Can somebody give an example of where you might see parallel lines in the real world? Devin.
In the streets.
Okay, and so tell me what you mean by that, because I can think of several things that could be in a street that would be parallel.
Like the sidewalks, if they're on the other side.
Okay, so the sidewalks on opposing sides of the street? I'll say opposite sides of the street. Okay.
Train tracks.
Train tracks. Okay. Okay, so the lines for the crosswalk, all right. So I'm going to call them boundary lines of the crosswalk. All right, great. Okay. All right, so let's talk about our perpendicular lines. So let's think about what would be a definition of perpendicular lines. What do you guys know is true about perpendicular lines? What makes them perpendicular and not parallel, or just lines that cross? Do they cross in a particular way? Nobody? Ethan?
Two lines that intersect.
They don't just intersect. They intersect in a very specific manner.
In a plane form.
Okay. Okay. I'm thinking a little bit more mathematically related than just they form an X. Okay. Nico?
All the angles are 90 degrees.
Okay. So I'm going to tell you the true definition. Doesn't say 90 degrees. What do we call an angle that measures 90 degrees?
Right angle.
A right angle. So the true definition are two lines that intersect to form right angles. See, geometry is very specific, and it's one piece at a time. We then know that the measure of a right angle is 90 degrees. So, funny, nobody mentioned angle measurements, though you guys should have already studied acute angles, obtuse angles, right angles, straight angles. Okay, those four angles you should have mentioned in years past. So, when we're in geometry class, we say the perpendicular lines are two lines that intersect to form right angles, and then we can go to the next level knowing that the definition of a right angle is an angle that measures 90 degrees. Then I can use a property called transitive, and I can put those two ideas together and say two lines that intersect to form 90-degree angles. But the definition only talks about right angles, okay? All right, so let's draw a little picture. And the only way that I know that those are right angles is that little right angle box, just like that, okay? Now, a symbol that we use to demonstrate we have perpendicular lines is an upside down capital T. That's a symbol, and you'll see it on protractors when you're measuring angles, okay? All right, can somebody come up with a real world situation that describes perpendicular lines? And there's, again, lots of them around all the time. Susie. Yeah. Intersection of streets. Now, it's not to say all of them are like that. I have a girlfriend who lives in Ladera, and there's roundabouts everywhere at the intersections, and those are not 90 degrees. You've got a circle in the center of these 4-feeder lanes that would be 90 degrees if you could connect them up, but they're broken up by this circle in the center. And that's done specifically to slow people down. Okay. Anything else you can think of in the real world that would be an example of perpendicular lines? You guys ever pass by a church? You see perpendicular lines at a church? The cross, yeah. Okay. All right. I'm going to pause for a second. Continuing on, let's talk about what happens, why understanding parallel lines and perpendicular lines can be very helpful, because it can help us prove other things. So the form I just gave to you has a ton of vocab words on it. So what I want to do is kind of go through the diagram and to illustrate. So this diagram starts with two lines that are parallel. And I can tell they're parallel because they do have a little triangle on the right side. But there wasn't just two lines, there was a third one. And if you notice, they labeled it with the letter L. So there's two ways to name lines. One is to come up with a lowercase cursive letter or italic letter, and that's called line L. The other way is to put 2 points on that line and label it by the points. So I'm going to put this on, but then I'm going to erase it. This could be point A, this could be point B, and then you could call it line AB, which would look like this. You would write the two ordered pairs, or 2 points, excuse me. I'm going to have to drop this down. And you would have a symbol of a line over the top. The order of those points don't matter, so you could also call it line BA. Okay, so those are different ways of naming a line. All right, ours, they decided to just deal with the lowercase italic L to name that line. All right, so I'm going to magically disappear all of those things. Okay, because that's not as important. And what happened when I drew this line, which, by the way, he has a name, and what does it say on that sheet that he's called? What's he called? Real loud? A transversal. And a transversal is simply a line that intersects 2 or more lines. And that's, again, up there. But you might want to highlight this or write it out. That intersects 2 or more lines. So when I do that transversal across these two parallel, and this is specifically with parallel lines, that we get actual physical relationships between the angles. And we create a total of 8 angles. So those angles break down into 2 big groups, and then they break down from there into 3, well, actually 4 groups that we'll be talking about. So here's the first group. If you have angles that are between your parallel lines, they're called inside or interior. So interior angles, angles. They are between the parallel lines. So 3, 4, 5, 6 are considered interior angles. So I use the symbol angle for angle 3, angle 4, angle 5, angle 6. Inside, interior. If you look outside of the two parallel lines. Those angles are called exterior angles. They're outside the parallel lines. Okay. Now, we have two different types of angles that kind of fluctuate from one side of the transversal to the other. So, for example, 4 and 6 are a pair. Three and 5 are a pair. So 4 and 6, angle 4 and angle 6, angle 3 and angle 5 are called alternate interior angles. They alternate from one side of the transversal to the other. They're interior because they're between the transversal lines. Then we have another grouping, angle 1 and angle 7, angle 2 and angle 8. So angle 1 and angle 7, angle 2 and angle 8. They also are on opposite sides of the transversal. If I drew one to the other, I'd cross that transversal. So they're alternate, but because they're outside the parallel lines, they're called exterior. So we have alternate exterior angles. Okay. Now here comes the fun one. And we have a lot of these. We have groups of angles that are in the same position on the parallel lines, but one's at the top and one's at the bottom. So angle 2 matches to angle 6. Shh. Angle 1 matches to angle 5. We've got angle 4 matches to angle 8. And then we've got angle 3 matches to angle 7. Because they share a common position, but one's in relationship to the transversal in the top of the parallel lines, one is in relation to the transversal in the bottom of the parallel lines. These are called corresponding angles. And did anyone write down what was true about corresponding angles? Pardon me? It has nothing to do with corresponding angles, the question I'm asking. Corresponding angles, the measures are the same. Now that's going to come in handy when you're being asked to answer questions, okay? If you know what angle 2 is, you immediately know what angle 6 is. If you know what angle 5 is, you immediately know what angle 1 is. So we can solve missing angles by understanding that corresponding angles are congruent, okay? So here comes the part that I'm not sure that you guys remember. Everybody good here? Okay, so here's the two or three that you should know from last year. First off, if we have two lines that intersect, and there's no mention of them being perpendicular, and they're certainly not parallel, and we form two angles, actually we form 4 angles, there is a name that we subscribe to angle 1 and angle 2, and it's the same name we would give angle 3 and angle 4. Does anyone remember what we call those types of angles? Okay, notice that they form a letter V, and that's the name of the angle. Okay. No. Anybody? These are called vertical angles. They have a common endpoint. Oops, sorry. And face opposite directions. The other thing about vertical angles is that they are congruent to each other. So vertical angles have the same measure. You're going to need to know that in order to do calculation on homework tonight. So angle 1 has the same measure as angle 2. Angle 3 has the same measure as angle 4. But I don't know about anything. Vertical is not angle 1 and angle 3. Okay. Now, angles 1 and angle 3 form what kind of angle? It's the same as what I get for angle 1 and angle 4. It's the same as what I get for angle 2 and angle 4. It's the same as what I get for angle 2 and angle 3. What do we call two angles that are side by? Will you guys stop throwing things around? We're taking notes right now. Ethan, your folder is not closed. What do we call angles that are next to each other that form what looks to be a line? What do you always want to tell me a line is? You always give me a qualifier for your line, and always tell you you're being repetitive, redundant. What kind of lines do you say you always have? Straight lines. So angle 1 and angle 4, angle 1 and angle 3, angle 2 and angle 4, angle 2 and angle 3 form what they call straight angles. Now, straight angles have a measurement. Together, they equal 180 degrees. There is a type of angle that you should have studied that also measures exactly 180 degrees. Two angles that when you combine them, they equal 180 degrees. They have a special name, and that's listed in your book. So if you look at page 373, right under where it talks about finding missing angles, the word shows up, I think, twice. What kind of angles are angles that form straight angles? What does it say? Supplementary. So straight angles are supplementary angles. And supplementary angles are two angles whose measures add up to 180 degrees. Okay. Now, we also call those four sets of angles adjacent angles because they form the straight line and they have a side in common. Okay. So what I want to do is for us to figure out, do some calculation problems. So practice. So I'm going to tell you that these two lines that are horizontal, those are parallel to each other. And I'm going to number my angles a different way than I did before. So 1, 2, 3, 4 goes down the left side, and then 5, 6, 7, 8 goes down the right side. And I start at the top and go to the bottom with those numbers. And I'm going to tell you this line is called A, this line is called B. Now, in geometry, you're usually given information. So in this particular one, through the diagram, I know that line A is parallel to line B. That's how I talk about things being parallel, is I use that symbol, okay? So line A is parallel to line B. Okay. Next, I'm going to tell you that the measure of angle 2 is equal to 105 degrees. So you know the angles have a label of degree symbol. It's a little open circle, almost like an exponent. When I want to talk about a measure, I put M in front of the name of the angle. When I want to talk about that angle, I take off the M. Okay, so it's two different ways of talking about things. Now, my question is, find the measure of angle 6 and the measure of angle 3. So what I'm going to do is put in what I know. Angle 2 is the same as 105 degrees. I'm going to circle up what it is they want me to solve for. I want to know what angle 6 is, and I want to know what angle 3 is. Okay? So, thoughts. Do I have any ideas what these angles could measure, and what could I use to help me figure out their values? Any ideas? Which ones would be 105? 6 and 3. Well, then you're telling me that angle 6 and angle 2 would be the same. And we just talked about those being making a straight angle, which equals 180. But if I add 105 to 105, that would give me 210, which is more than what a straight angle could equal. So nice idea, but that one wouldn't work for us. So let's try another idea. Nico?
5, 4, and 7 are 100.
So 5, 4, and 7 would be 105.
Yeah.
And tell me why.
Because they're perpendicular. That's right. Corresponding.
5 and 7 do not correspond to 2. Angle 2 and angle 4 are corresponding angles. And we know that corresponding angles are equal to each other, so I agree that angle 2 and angle 4 would have to be 105. Okay? What relationship does angle 2 have to angle 5, and what does angle 4 have to angle 7? What kind of angles are they? These are vertical angles. And we said that vertical angles are congruent. So I agree with all of your numbers, but that hasn't answered my question yet. Okay? So I've figured out 4 of the angles, but I haven't figured out the 2 that I need to figure out. So what else could I use to help me figure out the measures of my angles? Okay, so tell me then, what would we call angle 2 and angle 6 and angle 3 and angle 7? Let's do it that way. What kind of angles are angle 2 to angle 6 or angle 3 to angle 7? Cameron? Not acute. They're a straight angle. And the other word would be Supplementary. So Sophie came up with a good idea. She says take 180 and subtract the measure of angle 2. So this is the measure of angle 2. And that's going to give us what? 75 degrees. That's going to give us the measure of angle 6. Now, I could do the same thing with angle 3 and angle 7. Or, what kind of angles are angle 3 and angle 6? Not acute. That does describe those angles, but that's not the relationship that we're talking about in this particular problem. I don't know why you guys are packing up. I'm still talking. What kind of angles are angle 3 and angle 6? Alternate interior. Hold on. So these angles are alternate interior angles. And guess what we just proved is true about alternate interior angles? So this is angle 3 and angle 6. We also have angle 2 and angle 7. What do you notice about angle 2 and angle 7's measurement and angle 3 and angle 6's measurement? They're the same. So alternate interior angles have the same measure. So homework tonight is going to be practicing figuring out these missing pieces. Make sure you watch videos in the book if you need extra help.